Okay, in order for you to do your homework, I now need to explain Flask. So I mentioned before, you have your programming language, and now I'm going to talk about the framework, Flask, and then also the template system, and the template system is Jinja 2. So that's what the last part of today's lecture is going to be about. It's going to be about Flask and Jinja 2. So for Python, the two main web frameworks are Django and Flask. Django roughly follows the MVC pattern, and it takes quite a while to understand the opinion of Django in order to actually build a Django application. Flask was initially created as an April Fool's joke. Say, hey, look at my cool framework, and there was nothing in it. And as it turns out, people are like, I like no opinions about web frameworks. This actually works for me. It's very similar to, if you take the full stack course, it's very similar to Express. Like, it's just like the bare bones connector is what Flask is giving you. So it's called a micro framework. It's got a minimal approach to the way it builds things. So that's because I don't have a lot of time to teach you stuff. I'm just using Flask and just bare bones parts of Flask, so nothing too crazy. There's this is the documentation, and then for a minimal application in Flask, and then a scaffolded video that I like that I actually watched when I was trying to pick up Flask. So the directory structure of Flask is very simple. At the top level, you have an app.py, and this is typically your entry point into Flask. And then you have some assets. You have the static directory for all static content. So images, HTML files, they go in static, typically. And then in the templates directory, this is where your Jinja 2 templates are. So anything that you want to dynamically generate from a template would be stored in this directory. Here's an example of Flask's hello world. So in app.py, the first thing that you would do is import the package, import Flask. So hopefully you've pip installed Flask ahead of time. And then you set your application object to flask.flask, and then the name, you can actually specify the name of your app as part of the constructor. And then the simple app has one route. So here's where your decorator is. It says, I want to decorate the call app.route with / and this specifies the path. So I'm going to register a route that is the default route to / on the URL. So if I go to some website /, then that's what this route is going to specify. So it's registering / to this function. So this function is going to return welcome to my website as the base index page. The last command, it says, and this is sort of crazy, it says if __ name is main, then do an app.run. Now the reason why this is there, if you type Python app.py interactively, then you're gonna, the name of the app is gonna be main. So then it will run your app on host 0.0.0.0. This means I want connections from anywhere on the internet. If I would have put 127.0.0.1, then I would only accept localhost connections to my app. And then I specify the port. So the reason why this is here is because oftentimes Flask is invoked from a regular web server, like Nginx or Apache. And Nginx or Apache, they don't want Python to be running its own web server. So what this does is it runs the Flask's web server on this code. But oftentimes you want the hosting website, Nginx or Apache, to invoke this route directly. And this will be something in your web dev labs that you'll get firsthand experience integrating this with a regular web server. Okay. So those are all the parts of the Flask application. Okay. So we covered this before. How do you run your basic Hello World app? You create a virtual environment, you activate it, you do a pip install of Flask, and then you do a Python of your file, app.py, And then it basically will run on this URL, and then you can connect up to the browser, localhost 8888, and then get your web page that says, welcome to my site. Okay? So let's talk about the first version of this guestbook application. So when you do a git clone, it's in that directory webdev guestbook v1 pylist. This is a very simple MVC app, guestbook app, written in Python Flask. And as the name indicates, it's using a Python list to store your guestbook entries. So it's using just a data structure in Python to record all of the entries that have been posted onto the web app. This is the directory structure of the application. It has a base model class, and then it has a derived model that is going to be implemented using a Python list. It's got your main application file. It's got a requirements.txt file, which has basically Flask in it. That's the only package it needs. It's got a template file, or template directory, and these are the Jinja2 templates that it needs to do dynamic rendering. Because what it's going to happen, it's going to render things based on what the model has. So the model is going to have all the entries, and then this template is going to say, you know what, I don't know what those entries are, but if you send me a dictionary that's got all the entries in it, I will render all of those. I'll index through all of those entries and then spit out HTML is what the template's going to do. And then I have a CSS file that never changes that I put in the static directory. Okay, so I just went through this verbally, but that's what this just says. It's like a base class model, derived class model pylist. There is a stub, so I sort of lied here. There's model underscore SQLite, SQLite 3 there. This is a stub that has the same interface as model pylist, but you're going to implement a SQLite 3 backend for your homework. So you're gonna do the SQLite version of this model. The controller is in app.py, and then the view is in the Jinja2 templates in the templates directory. I should mention that this template directory, there are two files. There's the base HTML file, which is like the base class. All of your web pages will conform to this base class. So if you go to a website and you like the frame around it, like the header and the footer should all be the same wherever you navigate, that is very natural to be something that's inherited. Like you take a base and then the derived pages will inherit from the base and only change the middle parts of it. So that's basically what's happening here. There is a base layout that I put in here, and then the different templates around this base layout will just give you the subpages in the app. Okay. And then the requirements file, which has just got Flask in it. Okay, so I'm going to first start with the model. And the base class is in capital M model.py, and it defines initially two functions in it. So the two functions are the select, which returns the list of all the entries so far. And you can see with the model, it's the abstract base class. So it's just saying, hey, the select takes no parameters. And then right now, I want to return a list of lists containing all the rows of the database. This is my contract to the model base class. Anytime I call select, I should get a list of lists that contain all the entries. I could have specified a list of dictionaries. I could have specified any other kind of way to get the data back from the model. In this case, my base contract says this is the contract for all the bases. Like if any other derived model is implementing this, then they must also implement this select with that return value. So this is just specifying the interface. And of course, initially this is a pass because of course you're going to re-implement your own select based on the model that you implement in this class or in your app. Similarly, there's an insert call in the model that takes a name, an email, and a message. And of course, here I've done the right thing. I said param name, which is a string, param email is a string, and the message is a string. And then the return always returns true in this case, because I never make a mistake. And then you do make a mistake, but this thing will raise an exception if a mistake is made. And so you declare that, right? This is what's going on. And this is also an abstract method, so I'm going to say pass. That means that anything that derives from this has to have at least these two things. And if it doesn't, then you'll have an issue. Okay. So here's the implementation for model pylist.py. And it implements this model just using an ephemeral Python list. It's a list of lists, basically. And one of the things with storing the model in a Python list is that as soon as you Control-C the server, there goes your guestbook. It's not storing anything into a file. That's why like the SQLite 3 thing is what you're going to implement, because then that'll store the thing into a database file in the file system. So initially, I didn't want to clutter the app with a bunch of SQL or a bunch of file system rights. So initially, all this thing does is store it in a list that's ephemeral, that's in memory. And so the init function specifies that for this model, I'm going to create an attribute guest entries, and it's going to be the empty list. Anytime I get the select, I'm just going to return the entire list of lists that I have. All the guest entries get returned. And then on the insert, I am going to take these three parameters, name, email, and message. I am also going to get a timestamp, and this is just what I chose to store for a guestbook entry, is the name, email, the timestamp, and then the message in that order. And I just create a list with those four objects, and then I add it to the guest entries list. So I do an append. So this is, if I do multiple appends, multiple inserts, what I'll end up with is a list of lists, and each one of the sublists has 4 entries, one for each one of these parameters in the insert. Okay? So this is just about the simplest model that you could implement, and that's why it's in your version 1. Okay. So then I have the controller in app.py. It imports functions from Flask, and then set model, which is actually something in model.py, we'll get to. So I'm going to, from Flask, I'm going to import these particular parts of Flask. And these are utility functions to bind routes to names, to render the template in Jinja. So Flask has an interface to call the Jinja2 template engine, which is what render template is for. And then I have packages for the request. So when I'm submitting forms, the request object in Flask will say, well, what are the parameters that the user submitted? So that's what the request is. Redirect says after I submit a page, maybe I post my guest entry, maybe I want to redirect the user back to the home page. So that's what the redirect call does. And then what I'm going to do is I'm going to instantiate a model. So from model pylist, I want to make sure that this is the right model. I'm going to import the model that's defined in pylist to set the model. And then I'm going to create the app. So I'll create the app using Flask. And then I'll set the model to be whatever is instantiated with model pylist. And then I'm going to create these decorators. I'm going to say the route slash and the route slash index.html. Both of those routes will get served by this index. And the index function is just going to take all of the entries so for row in model select, this is going to get the list of lists from the model backend. And what this does is it creates a dictionary out of all of those entries for every row in model select. So Jinja likes to get things in a dictionary. So this is why I take a list of lists and then I create a dictionary of lists to send to Jinja. And then Jinja is going to index this data structure to render all of the entries in this thing. So I first get all of the entries. I get all the entries as a dictionary of lists, and then, or I'm sorry, a list of dictionaries. Sorry, I got them reversed. And then what I do is I send to the Jinja template engine, I send it to this template index.html, and I say, send it this data. And the Jinja template is going to go through this list of dictionaries and then pull out and populate every single entry in the HTML. Okay. Is that clear, what this code does? Okay.
That generate the dictionary
Per entry. There's a dictionary per entry.
per
Yeah.
entry.
Yeah.
So what's the lookup? Is the row that I don't understand?
The lookup will happen in the template. So right now I'm just getting all the data and then passing it to the Jinja 2 to render. And so the data format that I am assuming gets passed, this entries is basically a list of dictionaries where every entry is a dictionary of 4 entries in it. Yeah.
Oh, I see. Yeah.
And it's got the keys name. So the name key has row of 0. The email is row of 1. So those are the individual parts of the list. And it creates a dictionary with these named keys. Yeah, it's a little convoluted.
So it's a bunch of it's just a bunch of
It's a bunch of dictionaries. And if you want a different model, interface, you would just have to define your own. But I would recommend just keeping this. Since you wouldn't have to, you'd only have to extend it with the fields that are for your app, which we'll talk about later. Okay, the other part of the guestbook app is to sign the guestbook. So to sign the guestbook, you need a route that implements a post request that will handle an HTML form submission that includes a new entry. So that is what, in the app.py, you will see that as part of the file, you'll see that a route /sign, which will handle a post method. And what you're going to do is you're going to bind this function to handle that. That's what this is. So when I get a request to this URI with a post method, I'll invoke this sign function. And what the sign function will do is it will go to the request object. So as part of this request, Flask will give you a request object that says, these are the things that the client sent me. And as part of what the client sends you is a form. When you do a HTML form submission, there are named parameters in that form. It's sending you this as a dictionary. So the request.form object is a dictionary that when you give it the keys that are named in your HTML as part of the form submission, when you give it those field names, it will pull out what got sent. So that form submission for the name, email, and the message, and you can see in the UI, those are the 3 fields I asked for in the form submission. That's where these things get populated, and I can pull those and send those directly to the insert model, the model.insert, because that was my API for writing into the backend model. So then this just calls model directly to insert the entry into the database. And then what I'm going to do is after you give me the signature, after you sign my guestbook, I'm going to redirect you to the URL for index. So right at the beginning, I say the index route is going to be at the sort of the top level. And so this gets you to the base web page is effectively what the redirect is for. So you can see the entries that you have submitted. Okay. Yes? Oh, so this isn't in V1? Wait, this wasn't there. Okay, yeah. There's like 6 different versions of the guestbook because I wanted to show you 6 different things. So that's the reason. I'm not trying to intentionally confuse you, but like, yeah, there are different things that I wanted to show you, and it made sense functionally for the website to do the exact same thing, but then to show you different ways of doing what I'm going to have you do. Okay, so then the view is the next part of this, and this is done with the Jinja templates. So it's got the base page, as I mentioned before, which is like your base class, and then the subpages are derived classes. So the base page is in layout.html. And if you look at this, it's got this My Visitors title. It's got a style sheet, and this is also pulled from Flask. You can register a path for the static directory where all your static assets are located. And then within that directory, you want to pull style.css to include. Let's see how much time I have. 10 minutes. And then this, you can see that there is a div class page and it's empty. And you can see there are some directives in here. These are Jinja 2 template directives. It says there's a block that's named content that you would then include in here. And all the subpages will have this block content defined. And this is allowing you to get this as an outer frame for all of your pages in your app while changing the inner frame to be the form submission or the list of all the guestbook entries. So that's what this is doing. And then here's an example of a derived page that uses the layout as a base and then renders something in the middle. So this is the index.html that fills in the content block. And so you can see it extends the layout as the base class, and then it defines the content block. And that's all it does. So the base page is around this thing, but then within that div inside of layout, you have this guestbook app. So if you look at the guestbook, there is a URL on the base page to sign the form. So this is the form that's going to accept guestbook entries. And then you can see the names of each one of the inputs. So this is the name field, the email field, and the message field. And those were the things that you pulled out of request.form. So when you click on this form submission, it's going to go to the sign URL. And then request.form is going to be a dictionary created using these keys in the dictionary. And that allows your Python Flask code to pull out, well, what did these three fields, what did the user submit for those three fields? Okay. The last part is a for loop. So now I'm on the base landing page. I want the user to be able to sign the guestbook, but I also want to show them the current state of the guestbook. So for this, if you remember, anytime I call the index Python call, I pass the entries, the list of dictionaries that we had just talked about, I pass that into my Jinja template. And in Jinja has this for loop that says for entry and entries, go ahead and pull out entry.name, and this is a dictionary index, right? I take the entry as a dictionary, and I pull out the key name from that dictionary, and then I just print it out. So the name of the person who signed it, the email address, and then I also attach the timestamp because I generate that dynamically, and then I send the message there. So this is why I pass a list of dictionaries into this template, because the template is expecting these things to be dictionary, and each entry to be a dictionary, so that I can do that. Okay. These are ways in HTML to specify the less than and the greater than. So if you put the actual less than and greater than in here, it would assume it was HTML. And so this is HTML encoded, so that this will render a less than and a greater than, but it won't be interpreted as an HTML tag. Yeah. Instead of doing a backslash, because then, yeah. And you'll see, so this is where we have fun in web security, is that this throws lots of people, because if you can inject a stray greater than or a stray less than, you can inject a JavaScript file into a page. And then this is what, like if for example, if my message had opening and closing tags that would actually render on this page, then anybody who visited that page I could have them execute JavaScript. That's basically a stored cross-site scripting attack that you can invoke. So this is why you have to escape out any of these character sequences that you don't want interpreted as HTML. So in this case, I just want to render that symbol, but I don't actually want to parse it as part of my HTML. Okay. So we last left off on the version 2 of the guestbook, and this was a guestbook that was reorganized in the MVP pattern. So just to recap, the two things that this changed versus version 1 was that first of all, it isolated the model code. So now the model code is all in GB model, and I create this package, GB model, and it has these modules inside of it, and that's what I'm going to use to implement the different models. I have an abstract base class, capital M model. I have derived model classes in the PyList and the SQLite 3, and then I have an initialization script that will be executed whenever I instantiate the package, whenever I import that package for the first time. And then what I also have for this one is that I am organizing the application into this model view presenter pattern. And I'm going to do this with this thing in Flask called views. Now, initially, Flask didn't have any support for this, but then people are like, you know, maybe super bare bones is not quite enough. And so they added this thing as just a little bit of syntactic sugar in order to implement a presenter style pattern. In this case, you can see that instead of my monolithic app.py, I have an index.py and a sign.py, and associated with those two are the index.html and the sign.html that will implement. Together, the view, the presenter is implemented in these Python scripts, and their views, associated views, are in the HTML. Okay. So we covered this before, init.py in GB model. When I do the import GB model for the very first time, it's going to initialize. So in this case, I've hard-coded it so that it uses the PyList as a backend. And then based on which backend has been defined, it will import the model code from either the SQLite 3 or the PyList backend model. And because both models support the exact same interface for select and insert, they're interchangeable. Okay? And that isolates the model code from each other. So a SQLite 3 model code is in a completely different place than the PyList. And then but as long as I support the same interface, I can interchange. It's like Legos. I can interchange them. Okay. So the way that presenters are implemented in Flask is through something called a view. And so the presenter views, you can see, are defined here. So this line right here says that I'm going to implement a class called view, and this is going to inherit from flask.views.methodView. This is a particular way of organizing a presenter, and this method view, as part of this class, has multiple methods that you can override. One of the methods that you can override is the get. So the way this view works, it's organizing your functions based on the HTTP method that you have received. And so for this URL, for this particular presenter, it's got a URL, and then for each method that you can put onto that URL, there's a method associated with this. So this is the simple get. And whenever I get a get on this particular view, I just return hello world. And then, and this is just one monolithic file. I'll show you how it's split up later. And then in my app.py, I just say, I want to register this route / to this presenter. And then this is what the presenter is instantiated as. I need the view function. And it says view as view, and then I give it a label, main. And so this is a label that is just going to give me a handle on this particular view that I've instantiated here. It's just the name binding for that route is called main. And then everything else, the other thing I do is I just start the server. So this is the hello world of an MVP style pattern. This is how I've implemented it in this guest book. Again, I have app.py, and all that app.py does is that from each one of these presenters in index.py and sign.py, so that's what these two froms will look into. So if they're included in the same directory as app.py, then what it's going to do is within index and within sign, it's going to import the presenter index and the presenter sign. And then what the app.py does, it just registers the routes associated with the presenter, and then it labels the presenter as index and sign. So this is just labeling and routing the requests. The actual logic for supporting the presenters will be in these two files, and it will be implemented in the view. Okay, so the other thing that you have to define is the methods that your viewer will support. So in this case, the /route will only support a get, so you won't be able to send a post to that route. But then the sign method, the sign route, will support both a get and a post for you to process any form submissions. So that's the other part of the API for registering a presenter in your app. Okay, so then this is the presenter that handles the base landing page. And again, it is you see with this Python, it's basically a derived class from the method view. And then as part of this presenter class, all you need to do is override the get. Instead of the default get that method view gives you, I want to specify my own get for the landing page. And in this case, I'm just going to get the model. So this is the guestbook app. I'm going to instantiate the model. I've imported GB model, so that it goes into the model code. In init.py of GB model, I have defined this get model function that will return me a handle to the model I'm using. And then from this model, I can then just do a model.select, because that was part of the interface. And then for every row in model.select, this is exactly the same code as I had before. I'm going to create a list of dictionaries, and then I'm just going to render template, and then my view for this particular presenter is implemented in index.html, and I send it the entries. Okay. Similarly, so this is the index.html, and the thing that you can see, it extends that base layout, and then in the block content, it gives you the guest book. It gives you a URL to click on to sign the guest book. And if you look for, this is the syntactic sugar in Flask. I mentioned earlier that you're binding a route to a name for the presenter. That's what this is. When I say URL for sign, that's the route that I have established for the sign label. And it'll fill that in there with the actual URL at runtime. And then and this is exactly the same as you saw last class to present the guest book. Similarly, for sign is a presenter as well using the method view. It also supports this get. And with the get, it just wants to render the sign.html. So we'll see in the sign.html, the only thing that's there is the form for you to fill out. So if I'm going to hit this route with just a get, all I want to see is the form submission page that I can then submit the guest entry to, the guest book entry to. So that's all that's there. But on this HTML form, there's going to be a way for me to post a new guestbook entry. And that post is actually going to go back onto this particular route. So I do want to implement a post. So with the method view, I handle the get. And now I want to handle the post. And again, with the post, similar to the index, I just get the model. And then I do a model.insert. So this is part of my abstract base class. And I pull the things that got posted. So in the form, there's the name, there's the email, and the message. And then when I'm done inserting this, I will just redirect this thing back to the index route. And that will, because the index route, the way I've implemented it here, displays all the guestbook entries. Okay. Are there questions about this code and how it works? Okay, this is the HTML for signing. And if you see here, this is a simple HTML form. And the action is that URL for sign, which will be handled by sign.py. The method is a post. And so this is how we can get to one function versus the other in sign.py. And then as part of this post, you see the fields that I am then pulling out of the post: name, email, and message. And this is a submit type, where this button would submit all three fields. Okay, and this is what I want you for your homework. you're gonna create a form that's specific to bubble tea shops. You're gonna submit that, and then you're gonna render this using something similar to what I showed you on index.py. Okay. So are there questions about this version 2 before I move on? Because this is the code you'll be basically working with for your homework. Yes.
So index and sign are the models, and the GB models, it's like importing the appropriate version of the model.
These are the presenters. The index.py and the sign.py are the two presenters. So I can test those two things and interact with those two things independently. The models are in GB model. And then the views are the HTML. So when we saw that MVP pattern, it's like the view and the presenter associated with that view are all sort of organized together. And there's only one function in that presenter, and that is sort of bound to the view. And then there's the model backend. So it's like splitting the functionality out rather than having a monolithic controller. So the MVC pattern had all of the controller code sort of stored in app.py. This is attempting to split it out into different presenters. Yeah. And it's pretty basic, but hopefully you can see the idea behind the two different styles of architecting your backend. Yeah. Yeah. So yeah, the base HTML that is outside of this is the base class for the HTML has this as something that you fill in with a specific page. So sign, and so I didn't actually even show layout.html in this directory listing. It's there. I just wanted to focus on the things that changed. So yeah, there is a layout.html in that template directory, and you're gonna read layout.html first because that's what Jinja has specified, and that'll be your frame basically, and then within that there's a content block within layout.html that gets filled in with this. Yeah, based on the URL you're attempting to get. So when I established this in app.py, I bind a route to a presenter. And that presenter is either going to render index.html or sign.html, and that's where you select the HTML template to serve up. Okay, so one of the things with Python is that you'll end up wanting to deploy this on a production server, and as it turns out, you don't want to just say Python app.py and then make that open up the doors for millions of users out there, because the web server integrated into Python is not optimized for high performance. So typically, what you would want to do is you would want to handle most of your web requests. As many web requests as possible to your site should be handled by a web server that's optimized for that. And then you only want application-specific requests that require your Python to run to be handled by the Python interpreter. And so what you would end up doing, you'll have an app, a Python Flask app, and then what you'd want to do is when you want to integrate this with the production web server, you'll want to do, you can do it two ways. The first way is to manually configure an Apache 2 or an Nginx. These are open source web servers. Manually configure that so that the Python specific URLs will go to the Python interpreter. The other way to do that is to use some kind of serverless infrastructure and then let Google figure that out. Like Google or AWS, you're like, here's my Python app. This stuff can be served by CloudFront or Google Cloud Storage or some other way of delivering files. I just want you to run my app, right? So I'm going to show you the manual way to do this because you might actually run into a situation where you're manually deploying these things. But then by doing this, you'll sort of appreciate what goes on underneath in App Engine, because App Engine is doing this. It's just doing it for you, which is the point. And this will be the web dev lab. The very actually, I think there's only one web dev lab. Will be configuring this thing with Nginx. Okay, so the mechanism for them to make this work fast is this WSGI gateway. It's the web server gateway interface that allows the server to talk to any web app on the back end. So some implementations are UWSGI, mod WSGI for Nginx, as well as GUnicorn, which is what Google Cloud uses this for App Engine. So they're using that as the interface between their web servers and your Python code. There's mod Python for Apache 2. And what this is it's a reverse proxy that will take the incoming request going to your web server and then point it to the appropriate web application if the web application needs to handle it. This is what it looks like. I get a request to my website, and it's going to be handled by either Nginx or Apache. And they're going to look at this request and say, hey, this is for a static file. I'm just going to serve it directly. I'm not going to allow... Sweet. That would have been the end of the lecture, actually. All right, I'll be careful with this thing. Wow, I lost my place. Okay, so typically what would happen if it's a static file, Nginx is just going to process that immediately. And so anything in that static directory that I saw, like I mentioned earlier, like in the first version, there was the CSS file, style.css. Nginx would be like, you know what, I can serve that thing right now. I don't have to forward that to the Python interpreter to serve that particular file. So that's basically what's happening is a lot of the static assets, Nginx can just answer immediately. And it's only something like signing the web page or signing the guest book that I would then say the Nginx would be configured to route that kind of request through some kind of IPC mechanism on the web server over to UWSGI, and then this is the icon for Flask. This is where your web app would just handle that particular request. So that's typically the way it's deployed in production. And App Engine is hiding all of this for you. You're just deploying the app, and then as you do the App Engine deploy, it's deploying onto a web server that's configured to do this to route your stuff automatically so that you don't have to do the configuration. Okay. So with that, I'm going to walk you through the Web Dev Lab to talk about the different parts that you'll be doing to set this thing up. Get this here. So what you're going to do is you're going to, on your local Ubuntu VM, you're going to run the app locally just to see what it does. So you'll clone the repo, you'll go into version 3, you'll create a virtual environment, activate it, install the requirements, and this installs Flask and UWSGI. You'll run the app, you'll go to localhost 5000, and you'll see the guest book, and you'll enter in an entry. And then what you're going to do is you are then going to try and deploy this on a production server on a Compute Engine instance. So you're going to go to Compute Engine. You're going to create a Ubuntu 18.04 instance on an F1 Micro, and then allow both HTTP and HTTPS because you're not only going to integrate your web app on Nginx, you're also going to get an SSL certificate, a Let's Encrypt TLS certificate. So then, when you have launched this thing, take a note of the external IP address. So this is the IP address Google has assigned your instance. You're going to need to come back here and copy this address when we go and re-register a domain, because what I want you to do then is to register a domain name, a free domain name. And if you have your own DNS name, you can register it on that. But what I want you to do is register a DNS name, CS430- your Odin ID, on any of these free DNS services. So there's ipq.co, fdns.uk, noip.com. There's a couple other ones as well. There's freenom, nip.io, sslip.io, and zip.io. I want you to just create a name for yourself. And so any of these services, you can just copy and paste your IP address. So this is my IP address here. I copy and paste it into one of these sites, and then I want to register a DNS name that points to that. And then you'll see that the record has been created. And then this is the name that you own. And that compute engine instance, when it asks, let's encrypt for a certificate, because you own the name and the IP address, Let's Encrypt will sign a certificate for you to get an HTTPS cert for your website. Okay. And then I want you to SSH into the compute engine instance, clone the course repository, and then in this directory, I want you to go and look at the files that have been used to set the thing up. You don't have to change any of this. You just have to, I just wanted you to look for you to just be able to see what's going on in the back end. The first thing in this directory is this app.ini, and this configures the entry point for Nginx to go and enter into your app. So you'll see this WSGI is the name of the module, and then app is the function within that module that you're going to call. The number of processes I want to allocate for your app. So in this case, it's 1 because it's a simple guestbook app. And then the way of communicating from Nginx to your web app, and in this case, it's just going to be a socket. And then you can see in wsgi.py, there is an app that will run after you instantiate this. Okay, the next thing that is there are a bunch of templates to configure the system files needed. So the two things that we're going to configure are this systemd template to start up the UWSGI. So this is on your web app end. There's this thing called UWSGI that's going to handle any of those requests from Nginx. And it just points you to where you're executing the code from. And then it's creating it's going to your Python environment because you have to supply the environment that your web app depends upon. So this is how in this system template you can specify your Python environment. And this will get set up by the installation script. And then what you'll do is you'll execute that UWSGI program, and then Nginx and this UWSGI program will communicate with each other over that socket in the previous step. So again, this is not something that you have to cut and paste. This is given to you already in the repo. And this is just explaining what it's doing. The next thing is configuring Nginx. So you need to tell Nginx what parts of the routes are handled by Nginx and what parts can be sent off to UWSGI or your web app. And that's in this code block here. And so you'll see that programmatically project host will get substituted and project directory will get substituted. And then for this set of directives, you see that anything that has / will be sent over to the UWSGI process. Anything that begins with /static, well, I can actually serve those directly. So as with before, if I did Python app.py, the /static stuff will be served by the Python interpreter. By setting up Nginx this way, the static files gets delivered by Nginx. Okay. So the script that I'm going to have you run is this install.sh on your DNS name. And basically what this does is it pulls out your DNS name and then does a bunch of substitution to get your site name. So in this case, it pulls out the thing and substitutes the trailing dots with blank so that it can pull out CS430-Wu-chang instead of that whole domain name. It installs and creates the environment for your Python. So that's what this does. On that compute engine instance, it does an update. It does the install of all the Python 3 stuff that you need. And then it creates an environment in this directory and then activates it and then installs all of the packages you need to run your web app. Because default, that compute engine instance doesn't have any of your Python, so it has to be able to install Flask. And you have to put it in a place where Nginx can actually invoke it. And that's where that app.ini file came in to make the routing happen. The next thing that is there is to set up the systemd startup file for UWSGI. You want all of this to start whenever the machine is booted. right? You don't need someone to go in there and say, Python start this app. And that's what the next thing does. It actually adds all of the project user and the project directory. It adds that to this systemd configuration so that it will always start up whenever it's run. And you can see here it specifies the environment, the path to the environment, and then the uwsgi command that needs to start. So this actually, this allows you, when you actually reboot this compute engine instance, it will be running your environment automatically. Okay, and then it does some permission stuff on the compute engine instance because you do all of this installation and then it's owned all by root. And Nginx doesn't like running as root. It likes to run as data. So it's just changing a bunch of permissions to be data, and then it restarts the site that you have just registered. And then the last step is to obtain a TLS certificate. So what you'll do is you'll run certbot, which is the Let's Encrypt certificate bot. You say, I want this to be installed. I'm running Nginx, and then I'm going to give you the domain name. So $D$1 is your domain name. $1 is whatever you registered as a name. And then you're going to attach your email address here as the person to contact when the TLS certificate expires for renewal. Let's Encrypt forces you to renew your certificate every 90 days. And so this allows the email to go to you instead of me. I'm still getting emails when this used to have my email address on there. I've been getting emails like nonstop since that used to say my email address. And then this will actually go to Let's Encrypt and get Let's Encrypt to sign a certificate so that when this finishes, you get something that looks like this, right? You've got your URL. It's got a legitimate certificate so that when you click on it, you can see that it's been signed by Let's Encrypt, and you have your running app on a domain name. And this is where I want you to, so this is the command that you would run. It does all that stuff magic for you. It's going to take you a lot less time to run this thing than it just took me to describe all of that. But that's basically what you're doing. Okay. Okay, so that's it for the web dev part. Are there any questions? Okay.